Hello, dear students. How are you all? Preparing well for your term 1 exams? And of course, for this batch, that is 2021-22 batch, we all know that the board exams have been divided into two parts, term 1 and term 2. And of course, your term 1 exams are going to be MCQ based exams. Everyone knows about this very well. All your teachers might have told you so many times that students, this time it is going to be MCQ based questions. And when we are talking about MCQ based questions, there are positive points to MCQ questions and negative points. Of course, negative points is the marks are going to be digital. You are either going to get 1 or you are going to get 0. If your answer is correct, directly you are going to get 1 or you are going to get 0, right? But there are a few positive points also to this. Okay. The first and foremost thing is you need not write the complete procedure or you need not write all the steps to reach to the answer. This is not needed at all, right? Second thing is you can apply a few tricks, maybe a few shortcut tricks. I can say you can apply a few shortcut tricks so that you can save your time and get the answer very, very easily. Okay. The main thing which has come down for you is you need not write the complete procedure. You can just apply the tricks and all that, and you can reduce your time of calculations and you can get the answers very, very easily. Okay, so today I have come up with one of the tricks which we are going to apply for the chapter, a very interesting chapter which you have in your 10th grade, which is pair of linear equations in two variables. Okay, so this is a chapter which has so many methods are given over there to find the solution for a pair of linear equations in two variables, right? Before we begin with showing you the tricks and all that, let me just have a recap of what are the concepts which are involved in this particular chapter. Okay, we all know the general form of pair of linear equations. It is given by a1x plus b1y plus c1 is equal to 0, and the other equation is a2x plus b2y plus c2 is equal to 0. We all know that a pair of linear equations are those equations which are in the same variables. As in this case, you can see that these two equations are having variables x and y. Okay, they are in the same variable. That is why they are called pair of linear equations. And since there are two variables, they are called pair of linear equations in two variables. Here you have to remember your a1, b1 and your c1, and along with that your a2, b2 and c2. a1, a2 the coefficients of x, b1, b2 the coefficients of y, and c1, c2 the constants. All these are real numbers. Okay, these are the real numbers. And the condition which should be satisfied over here is a1 square plus b1 square should not be equal to 0. Similarly, a2 square plus b2 square should not be equal to 0. This is a very important condition. Keep this in mind. Keep it in mind. Always remember. Okay, so this is the general form of pair of linear equations in two variables, and these are the conditions which are there. Now, whenever we are talking about equations, whether it is a linear equation in one variable, you have seen that when you were solving it, you were getting a unique solution. When there was a linear equation in two variables, which you learnt last year, you know that there are infinitely many solutions for such a thing. But when we are talking about a pair of linear equations in two variables, there might be different types of solutions again. Okay. Basically, when we are talking about a pair of linear equations, okay, these linear equations could be of two types. These linear equations can be of two types. Okay, the first type is they might be consistent. They might be consistent. Okay, the equations might be consistent, and the other one is they might be inconsistent. Now, when do we call them as consistent and inconsistent? Whenever there is a solution to the pair of linear equations, then we call it as consistent solutions. Whereas when there is no solution, then we call the pair of linear equations as inconsistent. Okay. Now, under consistent solution, that is whenever there is a solution to pair of linear equations, again there are two types. there are two types. The first type is called independent consistent. Okay, it is called independent consistent. Now, when do we call the pair of linear equations as independent consistent? When there is a solution, of course. But when there is a unique solution, we call them as independent consistent. Okay, when there is a unique solution, we call them as independent consistent. Whereas the other one is dependent consistent. Now, when do we call them as dependent consistent? When there are infinitely many solutions. When there are infinitely many solutions, then we call them as dependent consistent pair of linear equations. And of course, when there are no solutions, that means what? There is not going to be any solution at all. Okay, so this is your inconsistent pair of linear equations. So remember, pair of linear equations, two types, consistent, inconsistent. When do we call them consistent? When there is a solution, we call them as consistent. When do we call them inconsistent? When there is no solution, then we call them as inconsistent. Again, consistent, it is divided into two types, independent and dependent. When do we call them independent? When there is one solution only, one unique solution. If there are infinitely many solutions, then it is called a dependent consistent pair of linear equations. Okay. Now, apart from this, I hope this is clear. This point is clear to everyone. Now, apart from this, a few things you have to remember. We know that there are two types of solving pair of linear equations, graphical method and algebraic method. Okay, but depending upon these ratios, okay, depending upon the comparison of ratios, we can find whether a pair of linear equations are going to be consistent or inconsistent, whether it is going to be a unique solution, infinitely many solutions, or it is not going to have any solutions. What is the nature of the graph that you are going to get? Whether the the linear equations are going to intersect at a point, or are they going to be coincident, or are they going to be parallel? It all depends upon these ratios of the coefficients of the variables and the constant. That is your A1, A2, A1 by A2, B1 by B2 and C1 by C2. So there are three conditions here. Let's look on to the first condition. The first condition is if A1 by A2 is not equal to B1 by B2. Now in such a case, remember, we are just comparing the first two ratios and we are seeing that they are not equal to each other. The moment they are not equal to each other, you should remember that it is going to have a unique solution. Okay. When you are solving this, you are going to have unique solution. If you are plotting it on a graph, you will have a graph which is going to be intersecting lines, which will show you intersecting lines. Okay, that means these intersecting lines of course intersect at one point, and this is going to be your unique solution. Okay, second condition. Now second comparison, we'll say A1 by A2 is equal to B1 by B2. When these two are equal, then we'll compare the last ratio as well. Now in the last ratio, if this is also equal to C1 by C2, then we say that there are going to be infinitely many solutions. Okay, there are going to be infinitely many solutions. And the equation, if the graph, we are plotting these equations and making the graph of it, this is going to be, the graphs are going to coincide with each other. Okay, it is going to coincide, right? That means if I have one graph like this, the other graph will also be coinciding on that. That means each and every point on the graph is going to be a solution, right? That's why we say that it is having infinitely many solutions, right? And since these two comparisons, when we are doing these two conditions, we are getting a solution. You can observe here I have unique solution and here I have infinitely many solutions. So this is called consistent. When the pair of linear equations are consistent, then we have unique solution and or infinitely many solutions. Now coming to the third comparison. Third comparison, suppose I have A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2. In such a case, you will have no solution. You are going to have no solution, and the graph when you are plotting, you will observe that the lines are going to be parallel to each other. You will have the graphs as parallel lines, something like this or this. That means they are not intersecting any point, they are not meeting at any point. That means there is no solution to the pair of linear equations. And this is called your inconsistent. In this case, it is going to be inconsistent. So if the question is given wherein you have two equations given to you, you just have to check you compare the ratios and check. If the ratios are the first and second type, that means it is going to be a consistent pair of linear equations. If it is of this type, then it is going to be inconsistent. A1 by A2 not equal to B1 by B2, unique solution, intersecting lines. A1 by A2 equal to B1 by B2 equal to C1 by C2, that means all are equal, then that means the line are going to coincide on each other, right? And it is going to have a infinitely many solutions. When the first two ratios are equal and the last ratio is not equal, like in the third case, A1 by A2 is equal to B1 by B2 not equal to C1 by C2, then you will have parallel lines and no solution. Okay. So this is very important. As such, this is very, very important. This is the basic thing which is needed for you to understand this chapter. Okay, all this is done. Okay, this was just a recap whatever we have done. Now I'll come to the major trick which I was talking about. Okay, this trick to solve a pair of linear equations, right? But before applying this trick, you should, have a little check of the equations. A little check needs to be there. What is that check? We all know that a1 x plus b1 y. Now here if the equation is given, you have to shift the constant to the other side, that is towards the RHS, right? The other equation also the same way. If it is like this, you have to shift the constant to the RHS. This is your first thing which you have to do. Second check, you have to check whether it is having a unique solution or not. How will you check whether it is having a unique solution? Compare these ratios. If these ratios are not equal, that is if A1 by A2 is not equal to B1 by B2, then you will say that yes, it is having a unique solution and I can apply this trick. Okay. So this was your second thing which you have to check. Okay, first thing is change that into such an equation where the constant is moved towards the RHS. The second one is check whether it will have a solution or not and whether it is going to have a unique solution or not by comparing these ratios. Okay, so once this is done, the next thing is you have to see to it that the first term, now which is the first term here? This is your first term in this equation and this is your first term in the second equation. Now in these two, you have to keep in mind that it should be having the same variable. You can't have a1x here and here you can't be having b2y. Okay, it should be the same variable. The first term should have the same variable. This is the next check which you have done. Okay. Now, after doing this check, we are going to apply a trick. These checks are needed, okay? You have to see to it that the constants are towards the right hand side. First term is having the same variable and a1 by a2 is not equal to b1 by b2. These checks you needs to be completed. Once you have seen that, just by looking at the equation, you will find out all this, right? So there is no need of much working for all this. Right, now we'll start using the trick. For using the trick, let me take one of the examples. Okay, so let me take the equation x plus y is equal to 5 and the other equation, let me take it as 2x minus 3y is equal to 4. Suppose these are the equations. Okay, now we are doing our checks properly. We have seen that the constants are towards the right hand side. So first check is done. The second check is whether the first term is having x variable. Yes, the first term is having x variable in both the equations. If it is y, that is fine. Okay, anything, same variable should be there in the first term. Okay, and then the third check, whether a1 by a2 is not equal to b1 by 2. Let's check 1 by 2. Is it equal to 1 by minus 3? No, it is not equal. That means even the third check is done. Now I'll show you how to apply this trick. Now keep your ears open. Everyone to keep their ears open. Now to get the value of x, we are going to apply one small trick. Okay? It says that x will be equal to r by alpha. Now don't get confused. I'll tell you what is your r and what is your alpha. Okay. For taking r, you are going to leave the first term completely. Okay. This first term you will leave it completely. You will start from the second term and you are going to follow this path of R. You're going to follow this path of R. Now what do I mean by following R? The path. You'll write x is equal to whatever you have taken. First term was x variable. So I'll write x. X is equal to. Now I'll follow the path. What is the coefficient of y here? It is 1. So I'll write 1. I'll follow this path of R. The next number I reach to is 4. I'll multiply 1 with 4. Okay. Then I'll put a minus sign. Again I'll follow this path of R. I reach to minus 3. So I'll write minus 3 into, follow this path of R over here. It is 5. So I'll write 5. Okay. This is your R. I hope you have understood it. Just follow that path of R. The coefficients of y, then the constant, then subtract coefficient of the second equation, coefficient of y, and then goes to the constant over there. Okay. That is your R. Now what is y? Alpha. Alpha is going to be here like this. This is your alpha. Okay. That means what? We are going to follow that path of alpha. We'll start from here. That is coefficient of y, which is 1. We'll go over here. We'll follow this path of alpha. What is the coefficient of x here? 2. So I'll write 2 minus. Okay. Follow this path again. It goes to x. The coefficient of x is 1. And then it comes down over here. Follow this path. You will get minus 3. Okay. Now solve this. Once you are clear with how to follow that path, you need not write all this also. It can be done in the mind itself. Okay. So if I'm just showing you it in detail so that you understand it properly. So this is 4. Minus of minus becomes plus 15 divided by 1 into 2 is 2. Minus of minus becomes plus 3. Right. So how much is this? This is nothing but 19 by 5. You have got your value of x very easily. Within 1 or 2 steps, you have got the value of x. Right? Now, once you have got the value of x, to get the value of y, you just have to substitute this value of x in any of the equations. Either you substitute here or you substitute here. I know if I substitute over here in this equation, it is very easy because x doesn't have a coefficient there. My calculations will be less. Right? So let me substitute the value of x in this equation. If I am substituting, I will get 19 by 5 plus y is equal to 5. Right? What do we do? We'll transpose 19 by 5 to the other side. So you'll get y is equal to 5 minus 19 by 5. Okay? This is nothing but take LCM of 1 and 5. LCM of 1 and 5 is 5. 5 5s are 25 minus 19. Yeah, how much is that? 25 minus 19 is 6 by 5. So you got the value of y also. Done. Your equation is solved. You have solved your equation. So easily you have solved the equation. Did you all observe? You have solved the equation so easily. And you have got your values of x and y. X is equal to 19 by 5 and y is equal to 6 by 5. Wasn't that easy? Wasn't that very easy? Should we take one more example? One example we'll take and we will solve it. Okay, one last example. So that the method, remember what is that trick? X is equal to alpha r by alpha. Get the value of x, do the substitution and get the value of y also. Okay, let's do one more question so that you understand this trick very well. We'll take one more pair of linear equations here. So let me take the pair of linear equations 3x plus 4y is equal to 10. This is one equation and the other equation is 2x minus 2y is equal to 2. Okay, suppose these two are the equations. We'll apply our trick. The trick says, of course, the first three conditions needs to be checked. What is the condition? Whether first condition is whether constant is towards the RHS. Yes, it is towards the RHS. Second condition is whether the first term of both the equation having same variable. Yes, they are having same variable. You can observe both are having x variable. Third condition, you have to check the ratio. 3 by 2, is it equal to 4 by minus 2? No, they are not equal. So, this condition is also correct. That means we are going to have a unique solution. Now, we'll write x we know is equal to r by alpha. Right? Now, let's make this path of r and alpha over here. This is r. Right? So, you will get x is equal to, we'll follow the path 4 into 2 minus 2 into 10. We have just followed that path. by alpha. Now where is alpha? Alpha is this, from here to here, like this. Okay. So this is nothing but 4 into 2 minus 3 into minus 2. Okay, solve this quickly. 4 2s are 8, minus of minus plus, 2 tens are 20. By 4 2s are 8, minus of minus plus, 3 2s are 6. So what do you get? You get 28 upon 14. Okay, and how much is this? 14 ones are 14, 14 twos are 28, so x value is 2. Now substitute. In any of the equations you substitute. Let's take the first equation. The first equation is 3x plus 4y is equal to 10. We'll substitute the value of x here, so we'll get 3 into 2 plus 4y is equal to 10. What do we get this as? You get 4y is equal to 10 minus 6, and that is nothing but it is 10 minus 6 is 4. So y is equal to 4 by 4, which is 1. So simply in such small steps you have got the value of x and y. X is equal to 2, y is equal to 1. Within few seconds you are getting the answer. Okay, substitution method you have learnt, elimination method, cross multiplication method. Actually speaking, this is just a method, a combination of two methods we have done, and we have got this trick. Remember, this trick we are using only and only because these are MCQ based questions where your working is not seen. Okay. If it would have been a subjective paper, definitely the working would have been seen, and then there you will be required to use a proper method and show these steps properly. Okay. So remember this method of x is equal to r by alpha, how to apply it, and solve your equations. Be careful with the negative signs. Negative signs will change your answers like anything. Okay, be very, very careful whenever you have that dangerous negative sign. Be careful with the negative sign and try to solve the equations. Okay. Yes, children, all the best. Very good. I'm really happy that you people are following me and trying to learn the tricks which I am telling. Continue following that. Practice, practice, and practice. Definitely, you're going to score very, very good marks in your grade 10 exams. All the best for your term 1 exams. Thank you.